Oh no, the world's coming to an end.
The sun is dying, and we need to go back in time to learn how to save it.
We're starting with the Big Bang, and when the universe began, scientists believed that every speck of the energy was jammed into a tiny point. This extremely dense point exploded with unimaginable forces, creating matter and propelling it outwards to make billions of galaxies and universes. Vast astrophysics dubbed this the Titanic explosion, the Big Bang. The elements in the universe are hydrogen and helium, along with trace amounts of lithium and beryllium. The most common elements in the universe are hydrogen and helium. These two elements comprise about 98% of the elements in the universe, with hydrogen at 75% and helium at 23%. The Big Bang happened 13.8 billion years ago, and the evidence is three key pieces of evidence are the observational evidence, one to support the Big Bang theory, the measured abundance of elements, the observed expansion of space, and the discovery of the cosmic microwave.
Now let's talk about galaxies. A galaxy is a gravitationally balanced system of stars, stellar remnants, interstellar gas, dust, and dark matter, and anywhere from a million to a trillion stars that are held together by gravity. Three different types of galaxies are elliptical, spiral, and irregular. The Milky Way is a spiral galaxy. The center of every galaxy is a massive black hole.
What elements were present in the nebula to form our solar system? Mainly in our solar system, hydrogen, helium are nebula. What force caused the nebula to collapse? Gravity can slowly pull them together. What direction do collapsing nebulas start spinning? Nebulas always collapse spinning counterclockwise. What about the moon and how it formed?
The moon formed when the rogue planet Theia collided with the Earth and knocked off lots of debris that formed into the moon. The moon formed 4.5 billion years ago. Earth and moon have very similar structures, dating the material to about the same time, providing the giant impact theory. The phases of the moon are new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent. Tides are when the gravity of the moon and the sun pull on the water on the earth, causing the water levels to rise and fall.
Well, molecular cycles largely affect the climate, causing the seasons to change. Molecular cycles are like a top spinning, and the axis is rotating. Centricity is one of the cycles. Centricity is the deviation from the orbit of the circle that causes it to be closer and further away from the sun, causing seasons. Precession is the Earth's axis spinning like a top on a table, causing the 6 months of brightness and 6 months of darkness at the poles. Obliquity is the oval or egg-shaped orbit causing the seasons. What advances have made as NASA, and what was the space race?
The space race was a race between the USA and the Soviet Union to be the first in the space. The first object put into orbit by man was the Sputnik satellite by the Soviet Union. Yuri Gagarin was the first man in space for the Soviet Union. The first two men to step on the moon were Neil Armstrong and Buzz Aldrin for the US. Satellite radio, missiles, and GPS were also made. How do we classify?
Well, the solar system starts with a young star that is called a protostar, and its gathering mass. A protostar forms in a nebula, and gravity causes dust and gas to clump together. These clumps gather more and more gas. This process is called accretion. Fusion in a star starts when two hydrogen atoms combine to form a helium atom. The protoplanet does one form. A large body of matter in orbit around the sun is built through the collision of small planets. The star and planets are different because stars emit their own light from chemical reaction in its core and don't orbit around the star. Planets are celestial objects that orbit around a star. It is classified in a stellar HR diagram. A scatter plot of different stars showing their luminosity and temperature. On the y-axis is measured the surface temperature, and on the y-axis is measured luminosity. There are 4 star groups: white dwarfs, main sequence, and supergiants. Each group fuses at their core. Main sequence fuses hydrogen to helium. White dwarfs fuse nothing. Giant stars fuse helium to carbon, and supergiants fuse helium. Our star is a main sequence star.
What about massive stars?
Massive stars range in SMU for anything greater than 8 SMU. They fuse hydrogen to helium, and when they die, they cause a supernova, and it creates all matter larger than iron. It is relevant to the formation of our solar system because massive stars relate to our solar system because they can create black holes, which can be the center of galaxies. When massive stars die, it creates a supernova. I want to know about all the stars and planets.
For average stars, the SMU is anything from 0.5 to 8 SMU. Stars spend the majority of their lives fusing hydrogen, and when the hydrogen fuel is gone, stars fuse helium into carbon. The more massive stars can fuse carbon into even heavier elements, which is where most of the heavy elements in the universe are made. Stars die because they exhaust their nuclear fuel. Average sized stars will die less dramatically. As their hydrogen is used up, they swell to become red giants, fusing helium in their cores, before shredding their outer layers, often forming a planetary nebula. The Sun, our star, has several layers beneath the visible surface: the core, radiative zone, and connective zone. These, in turn, are surrounded by a number of layers that make up the solar atmosphere. The corona is the outer atmosphere of the Sun. It extends many thousands of kilometers above the visible surface of the Sun, gradually transforming into the solar wind that flows outward through our solar system. The material in the corona is an extremely hot but very tenuous plasma. Sunspots are dark areas that become apparent at the Sun's photosphere as a result of intense magnetic flux pushing up from further within the solar interior. This causes cooler, less dense, and darker areas at the heart of these magnetic fields and in the surrounding photosphere, seen as sunspots. Solar flares are large eruptions of electromagnetic radiation from the Sun lasting from minutes to hours. The Sun outburst of electromagnetic energy travels at the speed of light. Therefore, any effect upon the sunlit side of the Earth's exposed outer atmosphere occurs at the same time the event is observed. The solar wind is a stream of charged particles released from the upper atmosphere of the Sun, called the corona. These particles can escape the Sun's gravity because of their high energy resulting from the high temperature of the corona, which in turn is a result of the coronal magnetic field. Terrestrial planets are called inner planets because they are the 4 planets close to the Sun, so they are the inner planets facing the Sun. Terrestrial planets are differentiated into 3 layers: a metallic core, a silica shell, and a volatile envelope of gases, ices, and, for the Earth, liquid water. The habitable zone is the area around a star where it is not too hot and too cold for liquid water to exist on the surface of the surrounding planets. The distance from the Sun is called the habitable zone, or the Goldilocks zone. Our home planet Earth is a rocky terrestrial planet. It has a solid and active surface with mountains, valleys, canyons, plains, and so much more. Earth is special because it is an ocean planet. The gas giants of our solar system are Jupiter, Saturn, Uranus, and Neptune. These four large planets, also called Jovian planets, after Jupiter, reside in the outer part of the solar system, past the orbits of Mars and the asteroid belt. The temperature of the early solar system explains why the inner planets are rocky and the outer planets are gaseous. In the outer regions of the solar system, where it was cooler, other elements like water and methane did not vaporize and were able to form the giant planets. A gas giant is a giant planet composed of mainly hydrogen and helium. Gas giants are also called failed stars because they contain the same basic elements as a star. Jupiter and Saturn are the gas giants of the solar system. An ice giant is a giant planet composed mainly of elements heavier than hydrogen and helium, such as hydrogen, carbon, nitrogen, and sulfur. There are two ice giants in the solar system, Uranus and Neptune. The International Astronomical Union downgraded the status of Pluto to that of a dwarf planet because it did not meet the three criteria the IAU uses to define a full-size planet. Essentially, Pluto meets all the criteria except one. It has not cleared its neighboring region of other objects.
Go.
Let's go save the universe, Brad.
Let's go.